Good day. This is a briefing on the two experiments in the Thermodynamics Laboratory. The first experiment is on refrigeration system performance test. Basically, we want to calculate the COP of the system as the load at the evaporator varies. And we are going to use two methods to calculate the COP. So in this setup, we vary the load at the evaporator by varying, of course, the current flowing through the heating elements inside the evaporator tube. So the load will vary from 200 to 1000 watts. And for each load, the evaporator pressure, condenser pressure, and the temperatures T1, T2, T3, and T4, this should be 4, will change. So the first method is basically using the H values. So basically we want to calculate H1, H2, H3, and H4. Basically you cannot calculate or find H4. You have to use the theory where the expansion process is asymptotic. So basically get H3 and H4 is automatically equal to H3. So in this experiment, we vary the load at the evaporator from 200 to 1000 watts. And we record all the temperatures T1 up to T4, as well as the refrigerant mass flow rate and the gauge pressure at the condenser and evaporator. And of course, we also calculate the power at the motor, and then from there we calculate the compressor power. The first method, using the H values, we need to find H1, H2, H3, and H4. As I said, H4 is equal to H3. This is basically equal to H3. To find H values, you need the pressure and temperature. So you can use steam table, property table. You can use graph for refrigerant R134A, or the easiest way is to use this program that I give you in the link. So you just click this and save the program. So you run the program, you get this window. So you just enter P evaporator, P condenser, and the temperatures T1, T2, T3. This is just a quick example. Let's say P evaporator is, this is absolute pressure, 0.1 megapascal. Let's say this is a quick example, 0.9. T1 is, let's say, -3. T2 is going to be 55. T3 is, let's say, 28. So the program will calculate for you H1, H2, and H3. And automatically H4 is equal to H3. It even calculate for you the COP. It's using the first method. For direct method, these are the loads at the evaporator from 200 to 1000 watt. We need to calculate the compressor power because COP is just Q dot 41 divided by W dot 12. But first we have to calculate the motor power. The data are all in the lab sheet. So from here, we calculate friction power. The difference between these two will give you the compressor power input. Between the motor and the compressor, there is a belt drive. So that's where the losses occur. This is how you estimate the losses in the transmission from motor to compressor. And finally, of course, we calculate COP using the direct method. So for the refrigeration system, you need to fill up this table and plot on the same graph COP using the H values and COP using the direct method. They're all versus T1. For the second method, the so-called direct method, of course, direct method and using the H values on the same graph. This next table is for the engine performance. So the second experiment is engine performance test. So the engine is a diesel engine, 4-cylinder, 4-stroke, each piston. The bore, the cylinder of the bore or the piston diameter is going to be 89 mm, and the stroke is L is going to be 100 mm. These last two information you're not needed in the calculation. The performance test is basically this standard test. One is constant speed, the other one is variable speed. Of course, we use a hydraulic dynamometer. If you want to know more on hydraulic dynamometer, just Google this keyword. So there are two tests. One is constant speed. So this is the speed of the engine. It's basically the speed of the crankshaft or the tachometer. In the actual car, it's the tachometer reading, 1400 RPM. So throughout the experiment, we vary the load on the engine from 1 to 6 kilogram, and we take the time to consume 50 milliliter of fuel for each load. In the constant speed test, since we vary the load, as the load increases, of course, we cannot maintain this speed. So in this test, in this assessment, basically we have to open up the throttle. In other words, supply more fuel to the engine. So fuel supply will keep on increasing. The second test, the variable speed test, we set the throttle at whatever throttle position that gives crankshaft speed of 1400 RPM. Leave it there. We just keep on increasing the load on the engine, and of course, the speed of the engine will drop. So for each test, we can calculate all these indicators: brake power, brake mean effective pressure, up to thermal efficiency of the engine. So here the flow of fuel, density of fuel is 850 kilogram per cubic meter. Of course, you convert to kilogram per liter, you get 0.850 kilogram per liter. So that's the value you use in these calculations. So for engine test, basically you just calculate and fill up this table. And for the variable speed test, plot on the same graph 3 curves, one for mean effective pressure, specific consumption, and brake thermal efficiency. They're all plotted against brake power. The same with constant speed test. Fill up this table And of course, include all the tables in your report. And do the same plot for the constant speed test. Just to check your results, the result should be within this range of values. The cylinder or the cylinder bore or the surface area of the piston is going to be pi on 4 bore squared. The bore is 0.089 meter. So submit your reports through the e-learning platform. Thank you.